So today I can be there, and one of you is going to be sharing this with the entire class by plugging your laptop into the board, and the sub will pause as needed. So to start with, we're going to talk about the fundamental counting principle, and I need you to write in your notes what is written on this slide. So the fundamental counting principle should be your title, and below it, it should say to find the total number of outcomes, multiply the number of possible outcomes for each event. That sounds really complex, but when I show it to you in a moment, it won't be all that bad. But I need the substitute to hit pause now and give you time to record this in your notes. Thank you. So an example of this is if I said I'm going to roll 2 dice and flip a coin. How many possible outcomes are there? So each time I roll a dice, there are 6 different numbers on a dice. And so each dice roll has 6 potential outcomes. So the first time I roll a dice, so this is my first roll, there are 6 possible outcomes. And then I roll it a second time, and there are 6 possible outcomes again. And then the next time I'm going to flip a coin, so this is my coin flip. And a coin has two sides, heads and tails, so there's 2 possibilities. So if you look back at the counting principle, it says that you need to multiply the possible events times each other. So we would do 6 possibilities times 6 possibilities times 2 possibilities. And if you do 6 times 6, that would be 36. And then 36 times 2 would be 72. So that means if I roll 2 dice and flip a coin, there are 72 different possible combinations I could receive doing this. So now I'd like you to try this problem. You want to buy a bike. There are 12 possible frame colors. There are 12 possible trim colors. And there are 2 handlebar styles. How many possible ways can you make a bike? So basically, like, how many different combinations are there for this particular bike? So I need you to identify all of the different variables. So if I go through here and look at this, I would say, okay, 12 frame colors, 12 trim colors, and 2 handlebar styles. So that would be 12 times 12 times 2. I'd like you to try that yourself right now. If the substitute would please hit pause and then see what some of the answers are in a few moments. So if you said that 12 times 12 is 144 and 144 times 2 is equal to 288, you are correct. There are 288 different ways that you could make this bike. The substitute is now going to pass out to you a paper, and it's going to have several different problems on it. I'd like you to start by putting your name at the top, and then the first 2 problems are actually 3 and 4. So I'd like you to start with number 3 and 4 and try those. If the substitute would please hit the pause button now, pass out those papers, and allow the students some time to work on it. Okay, let's go over problem number 3. If you look at problem number 3, it says, at a banquet, guests are given a choice of 4 entrees, 3 vegetables, soup or salad, 4 beverages, and 4 desserts. Wow, that's a lot of choices. How many different selections were possible? So we're going to go through and look at each possibility. So first it said that there were 4 possible entrees. So I'm going to write 4 times, and then I look back at the problem again, and it says, okay, in addition to the 4 possible entrees, there were also 3 vegetables. All right, so I'm going to add that, so times 3. Then again, if I go back to that problem, it states that they could also have a soup or salad. So right there, that's 2 choices. So times 2. Again, I look back at the problem and it says that they had 4 beverage choices. So 4 possible things they could drink and 4 possible things they could have for dessert. This looks like a lot of choices to me. Okay, so we're going to go through and solve this. All right, so we're going to do 4 times 3, which is 12. And then we're going to do 12 times 2, which is going to be 24. And then we're going to do 24 times 4, which is equal to 96. And then finally 96 times 4, which is going to be 384. So there are 384 different possible combinations of ways that you could assemble your meal at this particular place. All right, check your work, see if you got it right. And we're going to move on now to number 4. So let's look at what number 4 says. Number 4 says, Miss Nitobe is setting the combination lock on her briefcase. If she can choose any digit 0 to 9 for each of the 6 digits in the combination, how many possible combinations are there? All right, so again, she's got 6 digits going into this safe, and she can use 0 to 9 for each of them. Okay, so with the first possible digit, she can use anything from 0 to 9. So if you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's actually 10 digits that she can use. So there's 10 possible digits for the first number. And then for the second number in her briefcase, she can use all 10 of those again. She could have repeats. And then there's another number, so a third number, so times 10 digits again. And then there's a fourth number on the briefcase, and that's 10 more digits that it could be. And then there's a fifth number on the briefcase. Oops, fifth number on the briefcase, and that would be 10 more possible digits. And finally, our sixth number on the briefcase is 10 more possible digits. Whew. All right, so 10 times 10 is 100. 100 times 10 is going to be 1,000. My pen stopped. There we go. 1,000. And then 1,000 times 10 would be 10,000. And 10,000 times 10 would be 100,000. Woo! All right. So again, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. And then 10,000 times 10 is 100,000. And finally, 100,000 times 10 is going to be 1,000,000. So there are 1,000,000 different numbers that, or combinations, I should say. There are 1,000,000 different combinations that she could put in to her briefcase. And we don't have to actually list all of them to know that there's going to be 1,000,000. We can use the counting principle. So this is why this is really powerful, because if we had to make a list of all the possible things that she could put into her briefcase, we'd be here forever, because it would take a really long time to come up with all 1,000,000 possibilities. But we can use the counting principle to say, okay, well, there's 10 possibilities for the first, and 10 in the second, and 10 in the third, and 10 in the fourth, and 10 in the fifth, and 10 in the sixth. And if we multiply those all times each other, we're going to end up with 1,000,000 possibilities. Okay, so now I want you guys to try some more. All right, I know you can do this. Work hard, get through as many of those problems as you can, and I'm sure if you have some questions, you can ask the substitute and they will help you out as much as they possibly can. Oh, and just for a little bit of fun, you see how that one O looks really terrible? You can blame that on Kermit. Kermit, my dog, he bumped me while I was trying to write that O and made it a mess. So right there, it's all your fault, Kermit. All right. Again, I hope you guys are really good for the substitute. I want to see some great notes when I get back that you were amazing and tried so hard and were super focused and did all your work. Okay? Do a great job and make me proud. See you hopefully soon. Bye.